Good morning. We often talk about damp issues being multifaceted, and today's survey is no exception. I'll just pan you around and show you this building we're working on at the moment. So here we are. This is a 1935, 1940s left semi-detached house, 2-storey. It is cavity brick construction, also incorporating cavity wall insulation. So as we approach the building here, you'll notice that we've got an original blue brick damp-proof course in the external walls, which is appropriately positioned in relation to the ground. But if you look closer, you'll notice there bullet holes there from a chemical injection. You'll see to the front of the building we've got suspended timber floors, hence the air bricks, but also note they're at ground level, which is not ideal considering that the drive falls back towards the building, so there's a potential of water ingress through those air bricks. If we come around the side, you can see that this gully here has been replaced, and we've been flood testing the gullies for reasons which will become clear shortly, just to make sure that they're not contributing to any of the problems that we can see internally. Now if we take a look at the left external wall, you can see there is efflorescent salting in that brickwork there, about 4 to 5 courses higher than the DPC. And just down here we've removed one of those bricks, and as you can see there, the cavity is full. So I'm just going to walk you around the rear, show you the back of the house. So this is the back of the property here, and I'm just going to take you over to this gully here, the back of the kitchen. So what you'll notice is this is the waste pipe here for the kitchen sink, and as you'll notice, it doesn't discharge directly into the gully. Consequently, what's happening there is that water's being discharged at the back of the gully, leading to water saturating the ground at the base of the wall and running everywhere really where it shouldn't be. So that's not great. I'll just take you inside. Better turn that kitchen tap off first. Okay, so we'll take you through into the living room. As you can see, we've exposed the floor, turn back the carpet, and you can see there we've got a lot of dampness and mould and fungal rot in the floor surfaces. There's evidence of prior repairs to both the floorboards and joists. We come down, we'll have a look at these walls. There's a lot of mould growth, delamination and lifting of the paper decorations. Similarly, these skirting boards to the external walls are completely rotten here. When we look at the floor repair, we can see that that's been undertaken with non-treated timber. This is just CLS by the look of it, and the joists have actually been propped from the floor, whether in contact with the oversight or subfloor environment. And we've got moisture tracking up into the props too. And then when we start to look underneath, we can see all the discarded timber debris from the previous repairs and a significant amount of fungal wet rot decay. Looking at the subfloor walls, you can see we've got an extensive amount of mycelium there from the fungal growth and a lot of condensation forming upon the walls in the subfloor environment. The conditions in the subfloor are not good. As you can see, it's a very wet environment, hence why we were flood testing the drains externally, and the conditions don't get much better under the floor either. Now we've got, let's just show you, this is the internal dividing wall between the living room and staircase. Again, we've got wet rot decay of the skirting boards there, and when we test this wall plaster, the moisture readings taken from the plaster are very, very high. But that little hole there, that's a sample that we've taken from the structure, and we've analysed that on site with a calcium carbide meter, and the actual moisture content of the masonry was just 0.5%. So the wall here is dry, but the plaster and skirting boards are wet. The reason they're wet is a direct result of the conditions in the subfloor. This is humidity, condensation forming on the wall, wicking into the plaster, causes decay of the skirting boards. The only exception here is obviously where we've got this breach of the damp-proof course along this left external wall, and that's caused by debris in the cavity. We've also got some quite extensive damp around the chimney, party dividing wall. You can see the paper decorations here all lifting. The plaster beneath is generally spoiled and in poor condition. I'll just take you through towards the rear. The rear of the property has solid constructed floors. As you can see, we've exposed them here. And in the kitchen, if we look at the floors, give me 1 second, my meter gone. If we look at the floors in here, they are a combination of quarry tile in the understairs cupboard, which is traditional, original quarry tile floor. That's these quarry tiles here just laid on a bed of sand and lime, and then we've got a solid constructed floor elsewhere. Now you'll notice an awful lot of mold growth on the underside of this vinyl, which differs from the carpet floor covering in the hallway, and the reason being is that this is an impermeable covering, and what's happening here is the original concrete floor, which doesn't benefit from a damp-proof membrane, is absorbing moisture from the ground, and that's sweating underneath this vinyl. Now we've got our trusty Tramex meter here. Now this meter is designed and calibrated for concrete or other floor screed material. And we take moisture readings from the surface of the floor. You can see here they're about 6%. Now we want to be looking at the red line at the top, which is our moisture content equivalent for concrete, and I believe from memory that is actually based on a gravimetric scale with the floor screeds based on a carbide scale. From memory, you might have to double check that. We look at the left party wall here. We've got a lot of perishing and spoiling of the plaster, delamination of the paper decorations. The skirting boards here are wet, they're above 30%, so in fact they're not wet, they're saturated. And that little hole there, that's another calcium carbide test we've taken, and the results of that test were 10.5% moisture content, so that is again another wet wall. And if we start to look at the joinery around this solid floor, you can see here we've got a lot of decay here in the skirting boards there. It's all wet. Similar problems with the floor in this location and here, and the floor everywhere we've tested is wet above 60%. So as you can see, there are plenty of issues going on here. Damp isn't always a result of just one thing. It's not just the result of a breached DPC or something else. There are often lots of problems which contribute to the overall effect of dampness throughout the building. There's probably way too many issues here to explain them all and why it's happening, but I thought I'd give you a little introduction into what we have to do during a damp investigation to understand what the causes and influences are, and then eliminate what they are not. Anyway, thank you very much. Enjoy your day.